Welcome back, students. In this session, let us learn how rational numbers can be represented on the number line. You see here, let us suppose that this is an apple. Now I divide this apple into 4 equal parts. And if I take one part, then this is 1 by 4 of an apple. 1 by 4 of an apple. Again, let us see, this is another apple, and if I divide this into 3, now if I take this shaded portion and this shaded portion, since I am taking 2 parts and I divide the whole apple into 3, now this is 2 by 3 of an apple. Again, you see here is also an apple. If I divide into 2 equal parts, then if I take this shaded part, this is half of an apple. And here, this apple I divide into 5 equal parts. This is first part, second part, third part, fourth part, and fifth part. If I take this part and this part, it means 2 parts. Now this is 2 by 5 of an apple. And here you see, here is an apple, and I divide into this 4 equal parts. I take this portion, and this portion. That means 3 portions. Now this is 3 by 4 of an apple. Suppose in this case I take 2 apple. I'm keeping the first apple as same, but the second apple I divide into 4 parts. Then I take this part, this shaded portion, as well as this. So actually this is 1 whole apple and 1 by 4 of an apple. This is actually mixed fraction. If we convert this mixed fraction into improper fraction, 4 1 time is 4 plus 1 is 5. Now this is 5 by 4 of an apple. And we can think the first apple I'm dividing into 4 equal parts. Now I have taken this also, this also, this also, this also, and this 1 2 3 4 5. So 5 part I'm taking, and since an apple is divided into 4 equal parts, so 5 by 4 of an apple I'm taking here. And let us look here. This is a stick, and if I want to divide these 4 parts, this is 4 equal parts I divide. And if I take this portion of the stick, this is half of the stick. 1 by 4. 1 2 3 4. The whole stick is divided into 4 parts, and I have taken 1 part. This is 1 by 4 of the stick. Then let us suppose that this is another stick, and I divide this again into 4 parts, 1 2 3 4, and I have taken this also, and this also. Then this is 3 by 4 of the stick. This is another sticks, and I have taken 2 parts, and I divide this stick into 1 2 3 4 5 5 equal parts, 1, 2, 3, 4, 5. And if I have taken these two parts, this is 2 by 5th of the part of the stick. Here, this stick I divide into 6 equal parts. Here 1, here 2, here 3, here 4, here 5, and here 6. And I have taken 4 parts, 1, 2, 3, 4. Here I have taken 4 by 6 of the stick. This is what we are going to do on the number line. Let's see here, one question comes. Represent 1 by 4 on the number line. This is the line. If we divide this line into 4 parts, now the length of the line is from here up to that, and if I want to divide into 4 parts, and the 4 parts must be equal, so I divide here 4 parts, 1, 2, 3, 4. Since this is 1, I have to take the first part. So if I have taken this part, then I have to take from here up to that, and this point, and here we have to put 0, and from here up to this is 1 line, so 1. And if I take from here up to that, now this point A will represent 1 by 4, and if I take this is 2 by 4. If I take this is 3 by 4. If I take up to that, this is 4 by 4, and we know that 4 divided by 4 is 1, so 1 is same as 4 by 1. So we can write on the number line, A represents 1 by 4. Here it is finished. And let's see here, represent 2 by 6 on the number line. Here let's suppose that this is 0, 1, 2, 3, 4, 5, 6. Let us suppose that this is the 1. Here is 0, this is 1. I divide 0 to 1 into, since this is denominator is 6, I divide 0 to 1 into 6 equal parts. Actually this first part will become now 1 by 6. This is 2 by 6. This is 3 by 6, and this is 4 by 6, and this is 5 by 6, and this will be 6 by 6. So this is 2 by 6, 1, 2. So this point, let's suppose it be on the number line. P represents 2 by 6. Here it is over. And this is the idea how to represent rational number on the number line. Chapter number 1 continue. Representation of rational numbers on the number line. Any rational number can be represented on the number line. It says that any rational number can be represented on the number line. Example, represent 2 by 3 on the number line. So here is 0, 1, 2, 3. You see the denominator here, the denominator is 3. So 1, 2, 3. Now this will be 1, and this number 1 is same as 3 by 3. So 0, now this first point will be now 1 by 3, and this second one will be 2 by 3. And let us suppose that this is P. So now this P will represent 2 by 3 on the number line. On the number line, P represents 2 by 3. Let's take two rational numbers, 2 and 3. Actually, these two we can write as 2 by 1. Let's take 4, not 3, 4. 4 we can write as 4 by 1. If we want to find out a number between 2 and 4, we know that the number in between 2 and 4 is 3. But by calculation, we can find out the number between 2 and 4 like this. If we add 2 and 4, numerator are adding. If we add the denominator 1 plus 1, then 2 plus 4 is 6, and 1 plus 1 is 2. If 2 divides 6, that is getting 3. So, between 2 and 4, there is number 3. And we have to remind these steps. Suppose 2 by 1 is A by B, and let's take 4 by 1 is C by D. And if we want to find out a number between A by B and C by D, numerator we will add. Denominator will add together. So A plus C and B plus D is a rational number between A by B and C by D. Rational numbers between two rational numbers. If A and B are two rational numbers, then A plus B by 2 is a rational number between A and B, such that A is less than A plus B by 2 is less than B, and this is same as what I have told before. Now, note, there are countless rational numbers between any two given rational number. Let me explain this in Manipuri. A ga B ga sina any rational number ani oiba taragadi A ga B ga gi marakta laiba rational number du puthoke hai taradi A plus B by 2 sina oigani haiba aduga sidaida hai sina rational number ani gi marakta masing thingam daba rational number mayam ama lai haiba. Now, to understand more and to become a little refreshed, let us see a short video of number line.
Rational numbers on number line. Let us start this chapter by revising different types of numbers which can be represented on the number line. Let us first discuss about natural numbers. You cannot see 0 on the number line because natural numbers do not contain 0. Therefore, they are also called as counting numbers. You can notice that natural numbers extend from 1 to infinity. Now, let us move on to whole numbers. You can see that 0 has now appeared on the screen because whole numbers include natural numbers and 0. You can notice that whole numbers extend from 0 to infinity. Now, let us move on to integers. You can see that negative numbers have appeared on the number line. Integers include all natural numbers, their negatives and 0. You can notice that integers extend indefinitely on both sides of the 0. Let's move on to rational numbers. You can now observe fractions appearing on the screen. As you are already aware that a number that is expressed in the form of x by y, where x and y are integers and y is not equal to 0, is called a rational number. Notice that fractions also extend indefinitely on both sides of 0 on the number line. Now you can see a delicious pizza. Let us divide this pizza into 5 equal parts and see how we can represent this on a number line. As you can see, one piece of the pizza represents 1/5 of the entire pizza. Now let us see how to represent this on the number line. To represent 1/5 on the number line, you simply divide the number line between 0 and 1 into 5 equal parts. Mark the first division by 1/5. Similarly, mark the second division by 2/5, the third by 3/5, and so on. Now you can see that the first division, that is 1/5, represents one piece of the pizza on the number line. Similarly, you can mark any rational number on the number line. An important point to note here is that in case of rational numbers, the denominator tells the number of equal parts in which the unit has been divided, whereas the numerator gives the number of considered parts of this unit. Therefore, a fraction 3/7 represents 3 equal parts of 7. Now let us represent this fraction on a number line. Now, as explained above, divide the number line between 0 and 1 into 7 equal parts and mark these points as shown. Now, the third division represents 3/7 on the screen. Similarly, we can represent negative fractions on the number line. As you can see how -3/7 has been represented on the number line.
Now I hope that you have some idea about number line. Let's start exercise. Exercise 1.2. Question number 1. Represent these numbers on the number line. Roman number 1, 7/4. Here the question says that to represent 7/4 on the number line. Now solution. Here I draw a number line. When we draw number line, both sides we have to give arrow mark. And we have to look very carefully about the denominator. Here the denominator is 4. So before when I divide the stick into 4 parts and I have taken 3 parts, now this shaded portion represents 3/4 of the stick, and this number 4 represents how many parts I divide the whole stick. So here in this Roman number 1, this is 7/4. So from this 4 we know that how many parts we are going to divide. 1, 2, 3, 4. Now actually this point will represent number 1, and 1, 2, 3, 4. This point will represent number 2, and this first part will represent 1/4, and this second one will be 2/4, and this point will be 3/4, and this point is actually 4/4, and this is 5/4, and this is 6/4, and this point will represent this number 7/4. Let's put this as P. On the number line, P represents 7/4. Here question number 1 is over. Roman number 2, -5/6. Since here is minus sign, if there is minus sign, we have to be careful. So this is a number line. On both sides, I am putting arrow mark. Here one arrow mark, here one arrow mark. And now this point I represent 0. And you see the denominator is 6. So let's start counting. 1, 2, 3, 4, 5, 6. This point will represent -1. On the left side of 0, we have to give minus sign. On this right side, 1, 2, 3, 4, 5, 6, this point will represent number 1. Now on the left side of 0, this is minus 1 by 6, and this is minus 2 by 6, and this is minus 3 by 6, and this is minus 4 by 6, and this point will represent minus 5 by 6, and let's keep this point as B. On the number line, B represents minus 5 by 6. I hope you can understand this. Question number 2 is same, so you try as homework. Now let's try question number 3. Write 5 rational numbers which are smaller than 2. By this question, it says that we have to write down any 5 rational number, and those numbers must be smaller than 2. Now solution. We know here the given number is 2. 2 is equal to this number 2. If we want to keep in the rational number, then 2 by 1. Now write 2 by 1 again. Here numerator and denominator, let us multiply by the same number, that is 5. We are taking 5. If we like, we can multiply by 6 also, 7 also, 8 also, any number. You can multiply both these numerator and denominator by the same number. Here I am taking 5. 2 times 5 is 10, 1 times 5 is 5. Now 10 by 5 is getting. Therefore, five rational numbers smaller than 2 are, you see here is 10. If we want to take smaller number, this is 10, and 9 is smaller than 10, then 8, then 7, then 6, then 5. And in the denominator, this is 10 by 5. So in the denominator, we have to keep this 5. 5, 5, 5, 5, and 5. Here put comma. Therefore, 5 rational numbers smaller than 2 are 9 by 5, 8 by 5, 7 by 5, 6 by 5, 5 by 5. I'm taking those numbers which are less than number 10. That means 9, 8, 7, 6, 5. But in the denominator, we have to keep this number 5. Question number 4. Find 10 rational numbers between minus 2 by 5 and 1 by 2. Here the question says that in between these two rational numbers, we have to find out 10 rational numbers. This question is almost same as question number 3. Now solution. We know, first you take minus 2 by 5. Minus 2 by 5. Minus 2 by 5 into. In question number 3, in this 3, this 2 by 1 we are multiplying by 5. And here I told you we can multiply by any numbers that is convenient to us. So in this question number 4, numerator and denominator, let us multiply by 4. Here also 4, here also 4. These two multiplying numbers should be same. Minus 2 into 4 is minus 8. 5 into 4 is 20. And next rational number is 1 by 2. 1 by 2 is equal to 1 by 2 into. In this case, we cannot multiply by any numbers. We have to look here. In this denominator, to get 20, we need to multiply by 10. So 10, 10. 1 times 10 is 10. 2 into 10 is 20. Denominator are same. These two denominators should be same. Therefore 10 rational numbers between -2/5, this number, and 1/2 are, let's see here, this is -8, and we are going to write those numbers between these two. So -8, then the first number we have to write down -7. This, after this -7, this -8 is coming. Now 20. Next is -6. Next is -5. Next is -4. Next is -3. Denominator will be same, 20, 20, 20, 20. -2/20, -1/20, and here you can write 0/20 or simply 0. 1/20 and 2/20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 numbers in between -2/5 and 1/2. I hope you can understand this. Question number 5. Find 5 rational numbers between Roman number 1, 2/3 and 4/5. Here the question says that to find out 5 rational numbers between 2/3 and 4/5. Here in these two rational numbers, the two denominators are different. One is 3, one is 5. So in the solution, first we have to find out LCM of 3 and 5. LCM of 3 and 5 is 3 5 times 15, so LCM is 15. We know 2/3. To make this denominator 3 15, let us multiply in the denominator by 5. Numerator also will multiply by the same number 5. 2 into 5 is 10, 3 into 5 is 15. We are getting 10/15. Next is, and the second rational number is 4/5. Here denominator is 5. So to make this denominator 5, this number 15, we need to multiply by 3. So numerator and denominator will multiply by the same number 3, 3. 4 times 3 is 12. 5 into 3 is 15. Here we observe that here is number 10, here is number 12. In between 10 and 12 there is only one number, 11. So by this question it says that to find out 5 rational number, but in between 10 and 12 there is only one number, so we cannot find out 5 rational number in between these two. So we need to continue like this. 10 into 15. This 10 and 15 we need again to multiply by 4. 10 into 4 is 40. 15 into 4 is 60. 12 by 15. Here we are multiplying by 4. For here also by the same number we have to multiply. 12 into 4 is 48. 15 into 4 is 60. Here is 40, here is 48. Now in between 40 and 48 we are going to write down any 5 rational numbers, since we need to find out 5 rational numbers. Therefore 5 rational numbers between 2/3 and 4/5 are, since here is 40, right after 40 next number is 41. Next is 42. Next is 43. Next is 44. And 45. Denominator is 60. 60, 60, 60, 60, and 60. 1, 2, 3, 4, 5. These are the 5 rational numbers between 2 by 3 and 4 by 5. Roman number 2 and 3 are homework. Now question number 6. Write 5 rational numbers greater than -2. Now solution. We know -2 is equal to -2 in the denominator is number 1. So -2 by keeping the denominator 1, -2 by 1, both numerator and multiplying, let us multiply by 10. -2 into 10 is -20. 1 into 10 is 10. Now we are getting -20 by 10. Here the question says that to find out 5 rational numbers greater than -2. So -2 becomes this number. Now we have to write down 5 rational numbers which are greater than -20 by 10. Therefore 5 rational numbers greater than -2 are, this is -2, we need to this is -20, and we need to write down the greater number than that. So we know that -19 is greater than -20. Next is -18. Next is -17. Next is -16. And next is -15. And here denominator is 10, so all the denominators will be 10. So these are the 5 rational numbers greater than -2. Question number 7 is same, so you try as homework. Here chapter number 1 rational number are over. In the next session we'll learn chapter number 2 linear equation in one variable. Okay, thank you all.